Let's go. All right. So finding the midpoint. The first thing I'm going to do is just take the averages of the x's and the averages of the y's. So I take 2 plus 6 divided by 2, and I'll take negative 5 plus negative 3 and divided by 2. Okay? And I just call it MP, for midpoint. And so that's 8, right? And then this is actually negative 8, right? And so then we get 4 and negative 4 for our midpoint. Okay? Which is really important to look at on a graph, right? And so if I'm looking at 4, negative 4, and I'm looking at 2, negative 5, and 6, negative 3, maybe I don't want to start this thing in the middle so much, as I want to start it more like up like this. Does that make sense? When I'm putting it on my paper, and then I can start looking at so it goes 1, 2, and I really want to keep these the same distance, right? If you can use graph paper and then paste it onto your thing, that's even better. Maybe what I'll do on the test is I'll try to put a piece of graph paper on there, or I'll print a graph on there so you can just graph it, so you can see it. This isosceles triangle is a lot more fun of a problem when you're looking at it rather than when you're trying to just do the math. So this is 2, negative 5. So we're at like right here. And then 6, negative 3. So this is that makes sense? Okay. And then we found our midpoint to be 4, negative 4. And if it doesn't fit, if it doesn't look like a midpoint, then something's wrong, right? Does that look like a midpoint? So we're good. All right. So the next step is, let's figure out how long this distance is. Okay? So, distance formula says that the distance is equal to the square root of, and so we take the difference of the x's, right? So, I'm just going to do this, because I like to do the x's on the bottom, right? And the y's on top, because eventually I'm going to want the slope, right? And I don't like to mess my brain up. I always like to deal with it so that later on, if I'm finding the difference between x and y, then I know that, I could use that as slope later on. Does that make sense? And I might need the slope. Hence, we do, because we're going to be asked to get the perpendicular. So I like to look at these differences here. And so I'm like 2 minus 6 would be minus 4. Does that make sense? Okay? And then negative 5 minus 3 would actually be a minus 2. Right? Yes?
Then why does it say like x2 minus x1?
Because you can do it that way also. So I can take this one away from this one, right? And I can take this one away from this one, as long as I do it in the same order, right? You should have learned that when you learned slope, is that it doesn't matter which way you find it, it's still, as long as you go in that order, right? And that's why I like the flip it smack it method. I don't know if you've ever heard the flip it smack it method when I do slope, but flip it smack is pretty easy. I just put them in order called a matrix. So 5 over 2 negative 3 over 6, right? And then I smack them. Boom, boom. Right. And when you smack something, like you take your baby's hand when she's grabbing the plug on a plug, you know, plugged into the wall, you smack her hand, right? Because she's doing something negative, so she doesn't do it again. So it becomes positive, right? But then if they're doing something positive, like helping you with the garbage, and then you smack their hand, now they don't help with the garbage anymore. That's kind of, you're turning something positive into a negative, right? So that's kind of, you know, how I like to think about it. And that's slope, but we're not dealing with slope yet, right? But that's the flip it, smack it method. And that's just saying, it doesn't matter which one. I could have put this one out in front. I could have put negative 3 over 6 and negative 5 over 2. I'm still going to come up with the same number, right? In the end. In the end, it's still going to be 2 over 4. And this is going to be negative 2 over negative 4, which is still 1 over 2, which is still 1 over 2, right? So no matter which way you do it, it's still going to be 1 over 2. In the same aspect, no matter which way I do this, right, it's still going to be negative 2 and negative 4, right? So my x's are the negative 4 squared, right? Plus my y's, the difference in the y's, right, is what? Negative 2 squared, okay? And so when I square these, I get 16 plus 4, okay? And that's the square root of 16 plus 4, which is the square root of 20, right? Yes, ma'am?
Isn't it second x minus first x?
We just discussed that for
No, I
about
know,
5
but
minutes.
that would be, wouldn't that be first x minus second x to get
Yeah.
negative 4?
Uh-huh.
So you can flip it.
You go either direction. Yes, ma'am. But, like I said, you have to do it with both of them. If you make your x the first act, because think about it like this. What if I wrote these in this order? Right? It'd still be the same problem, right? So all we're doing is we're making sure that we do it in the correct order each time, right? So if I make this one first, then I have to make this one first. If I make this one first, then I have to make that one first. I personally have dyslexia, so when I make the second one first, I always mess up. I almost always plug in a value wrong. And what I notice with students, they do the same thing. So just because the formula says it's like this, you have to understand what you're doing in the formula, right? And once you understand what you're doing in the formula, right, then you can start manipulating the formula like what I just did. Like, I don't care in what order I put them in, right? They still, if I do it correctly, they still come out to be 1/2 as a slope, right? But in this case, they're still going to be either 4 or negative 4, right? And in that way, when we square it, it doesn't matter anyways, right? When you square a negative, it becomes positive, right? So, yeah. So if you like to plug it in to the formula, the way that it's set up, as long as you're getting the correct answer, I'm happy. But if you're finding that you get the wrong answer a lot, you might have an issue with dyscalculia or dyslexia, and then you might want to start thinking about using a different method of plugging in your values. Does that make sense? All right. But nevertheless, we come down, we get 20, right? Now how do we break down 20?
4 and 5.
That's it. So I like to think of it as 2, 10, 2, 5, 5, 1, and then I pull out my pair, right? And now I've got 2 square roots of 5, right? That's how I teach it. You guys might learn, pull out a 4, and you know that the square root of 4 is 2, so you pull out a 2. Does that make sense? However you do it, as long as you come up with 2 square roots of 5, I'm happy, because that's what you need. Okay? We need to know that the distance is 2 square roots of 5. That means that this distance is the square root of 5, and this distance is the square root of 5, which is really important. Okay? Are we good so far? Right on. Alright, so that's the first problem. So we'll pause it there. Questions though on this before we pause it? I just want to make sure we're all clear before we move on to the next part of this problem. Okay. So we pause this.